This is problem number 14 from chapter 10. Here we have SAT study course and is tested in 12 individuals. Pre-course and post-course scores are recorded. Of interest is the mean increasing in the SAT scores. So we're looking for an increase for the pre and post. Let's see. I think it would be good if we label these as sample 1 and sample 2. So we're looking at two samples, and clearly they are matched pairs. So this is two sample matched pairs. And whenever we have a situation like that, what we're going to do is we're going to find the difference between them and combine it here. And so we're going to make a list, and then we're going to look at the difference, and we'll call it pre minus post. And there are several ways to do it. If we just remember that it's going to be the group 1 minus group 2 always, and then adjust your claim in a certain way so that it's addressing this idea that the mean increase in SAT scores, then we'll just logically think about that. What does it mean for an increase from the pre to the post? And then we'll set up our equations that way. So if we, in general, take a look at, well, let's set up our hypothesis already, our null and alternative hypothesis. If we have the mean from the pre-test, and then the mean from the post-test, and remember that this is 1 and 2. If we have a mean increase in SAT scores, then that means we want this to be higher. And our sign would look like this. But what we're actually going to do is we're going to combine them by finding the difference. I'm not going to do this for all of them, but I'm going to look at the pre minus the post. So this is a 1200 minus 1300. Now we have something larger that we're subtracting, so we're actually going to get a negative number here. So negative 100. And we're going to do the subtraction here. This time it's 960 minus 920, so this is going to be a positive 40. And we have 1010 minus 1100, which is going to give us a negative 90. So I'm just going to put dot 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 here, and I want to have my calculator figure out the rest. But this is a general idea. What we're going to do from here is, when we get all these differences figured out, we're going to create a new list, and we're going to do a test on this actual list. And so from this list, we're going to find the mean difference. We're going to find the standard deviation. Let's call it an S since it's from the sample. And then our N, if it's going to be needed. Actually, it's just counting this. So it looks like there's going to be 12 of them. I guess we could have just looked here and found that there was 12. So we're really going to combine these two samples into one. And so we're going to want the mu as a difference of mu1 minus mu2. So just by doing some algebra, if I had call this just a regular inequality, if I subtract mu2 from both sides, I'm going to keep this sign to be less than 0. So mu1, or mu pre, and then mu2, that's the post-test, is going to be mu1 minus mu2. And I'm going to call this mu sub d is equal to 0. And actually, I think now that I'm looking at this, I should have, this is coming from the sample, so this should have been x bar with the D in it. Alright, let's get this thing set up. So this is going to be our claim. And if this is our claim, then let's do this in a different color here. If this is going to be our claim, then our null hypothesis is going to be the opposite of that. So mu sub d is bigger than or equal to 0, and then our use of alternative hypothesis is exactly what we have here as our claim, less than 0. Okay, so because this is a two-sample with matched pairs, we're actually going to use a regular t-test. So let's go to our calculators and let's look at all the test options. Well, we don't need to look at all of them because the t-test is the second one there. Oh, before we do that, we need to put this in our calculator. So let's go back to stat and edit. And I've already listed the L1 and L2 list here, 1200, 960, 1010, etc., 1300, 920, and 1100. Now, to get my difference, I'm going to go move my cursor up to L3. Notice this is L3 without a parentheses. This is the cursor is up here highlighting L3. And I'm going to want 1 minus 2, so I'm going to want my L1. L1 is obtained by hitting the second function and the number 1. So L3 now, again without the parentheses, is equal to L1 minus L2. Now if I press enter, I'm going to get the differences there. And I got negative 100, positive 40, negative 90, and then this fills out the rest of them. So I have my L3 list that I'm going to do a test, my t-test on. So I'm going to go back to stat. And number 2 is a t-test. And I have data inputted in. So I'm going to select data. And my mu sub 0, mu sub d actually, is going to be a comparison with 0, so I need to type in 0, enter. My list, remember this thing landed in L3, so I want to use my L3 list, so second function and the number 3. Frequency is going to be 1. My alternative hypothesis is the claim. So this is important that we actually use the one tail, a left tail test. And so we need to select that to guarantee that we're using a left tail test. Alright, let us calculate this. So we got a t-test statistic. So let's write it down here. Test statistic is a t-value. That makes sense because we're using a t-test. A negative 2.72. Our PV, our p-value is 0.00995,996. So it's a small number. You notice that your test statistic is farther away from 0. Over 2 standard deviations away, well, sort of some measurement of standard deviations away. And then we have our p-value that's going to be less than 0.05. Alright, so it looks like we're going to reject the null hypothesis. Before we go on with that, let's just take a look down here. If we needed to, if we were asked, we have our x bar, our xd bar, which is negative 41.667. And our standard deviation for our sample is 53.058. And then we have n is equal to 12. Alright, let's finish this up. We have our PV, since our p-value is less than any conceived alpha we could have thought of, 0.05, 0.01, or anything like that, we're going to reject the null hypothesis. And remember that we're testing the null hypothesis, so we're rejecting the null hypothesis. Now, if we reject the null hypothesis, this gives rise to supporting our claim. And so therefore, we can conclude the sample data supports our claim. Supports the claim that, what was our claim again? Our claim, if you remember, is that the mean increase, there is a mean increase in SAT scores after following this course. That there is a mean increase in SAT scores after taking the course. And as you can see, this is an important test that's used in a lot of real-life situations, especially with the pre and post test that people often do when they're trying to support their programs. And so if there's a course that somebody has and they want to show its effectiveness, they give a pre and a post test. And then you would run this t-test where you're comparing the data and then finding the difference between them. Alright, so hope this helps with your homework.